Hello guys, welcome to Basic Chemistry Plus, and today we are going to continue from where we left the last session. So in the last session we have talked about the different sort of intermolecular forces like the Keystone force, like the Debye force and the Landon force. And then I told you there are two more types of forces left over there. Those are ion-dipole interaction and hydrogen bonding. So today we are going to start with those two forces. If you do not know what I'm talking about right now, about the intermolecular forces and the Keystone force, the Debye force, all these things, then feel free to reach out to my previous video. The link would be given in the description. Now, today we will start the session with the first thing, which would be ion-dipole interaction. Ion-dipole interaction. Now, what is this? I think you have heard about this interaction a number of times earlier as well, but you have never paid attention or you have not recognized that interaction that time. So now I'm going to show you what happens in ion-dipole interaction is, let's say I am dissolving NaCl in water. So I'm trying to make an aqueous solution of NaCl. If I try to do that, then what would happen is I would get Na plus ion and I would get Cl minus ion, and both of them would be aquated, or both of them would be hydrated, isn't it? This is what happens. Now the point is, you have heard that this word like dissolves like dissolves like means if you have a polar solvent, it would dissolve the polar solute. So polar solvent can dissolve polar solute, right? Polar solute. Similarly, non-polar solvents can dissolve non-polar solute. As simple as that. Now, how is it happening? So the main reason behind this, like the polar solvent can dissolve polar solute, is coming from this ion-dipole interaction. So let's look into it. What happens is when this Na plus, when this sodium plus is getting dissolved in water, what happens over there is, let's say I have sodium and I have water molecule. Now, if I have sodium molecule, sodium ion, if I had dissolved that thing with water, you know that sodium gets dissolved in water very easily, right? Now, why is it happening? So what happens over there is when Na plus gets dissolved in water, the water molecules are polar in nature, isn't it? Because you know that oxygen is more electronegative, so it pulls the electron cloud of this sigma bond as a result of both the sigma bond actually, and as a result this oxygen becomes delta negative, whereas this hydrogens, they becomes delta positive. Now this delta negative and this ion, so what is this actually? This is a dipole, isn't it? This is the dipole, right? And what is this? This is an ion. So that's why we call it an ion dipole interaction. Okay, this is another type of intermolecular force. Now, moving on to the last type of intermolecular force, which is known as hydrogen bonding. So, hydrogen bonding. Guys, I think you know that in biology, you have heard about DNAs, right? In the DNAs, you know that there are adenine, thymine, guanine, cytosine. These are the bases, right, in a DNA. And like, have you seen these type of structures? Like in DNA, there are double helix structures. I think you have seen that. There are double helix structures. Now, in these double helix structures, they are either connected via two bonds or sometimes they are connected via three bonds. Look, adenine and thymine, they gets connected by two bonds, and guanine and cytosine, these two bases gets connected via three bonds. These bonds that we are talking about over here, they are hydrogen bonds. Okay. Apart from that, I think you have heard about why ice floats on water. The answer to that question is also hydrogen bonding. So apart from that, why water is liquid? It's not gas like NH3 or HF. The answer to that question is also hydrogen bonding. So hydrogen bonding answers a lot of questions. So for that reason, hydrogen bonding is a very important topic of this chapter. Now, you have heard about this hydrogen bonding in chemical bonding as well, right? In the end of the chapter. So what is hydrogen bonding? Hydrogen bonding is something which is shown by bond, fluorine, oxygen, and nitrogen. Because you can understand that the electronegativity order of this periodic table is the highest for fluorine, then goes for oxygen, then goes for nitrogen. This is the electronegativity order. So definitely they would show the hydrogen bonding. Now, how do they show hydrogen bonding? What is the mechanism? So what happens is when you have two molecules of HF, let's say I have one HF, okay, and I have another HF, okay. Now what happens is this fluorine is more electronegative, so it would drag the electron cloud more toward itself, just like the previous question. As a result, this fluorine would become delta negative, and this hydrogen would become delta positive. The same thing would happen over here as well. The electron would get dragged towards this fluorine atom. The hydrogen would become delta positive, and the fluorine would become delta negative. Now, if you have noticed, in between two HF molecules, this is an HF molecule, this is another HF molecule. But in between two HF molecules, there is a force of attraction getting formed, isn't it? Now, this force of attraction is not like Kisom's. Yeah, you can say that this looks more like Kisom force only, but this is stronger. This is very strong, right? Even stronger than the Kisom force. So this force, this type of bonding is called hydrogen bonding. Where else do we see this bonding? Definitely in oxygen and in nitrogen as well. So if I give you an example, small example of water. So in water, there are four hydrogen bonding around one molecule. So one hydrogen bonding from here, one hydrogen bonding from here, one from here, one from here. Remember, oxygen would always connect with hydrogen, and hydrogen would connect always with oxygen. Like this. So this is all of them. All of them are hydrogen bonding. This is also hydrogen bonding. This is also bond. So these are the hydrogen bonding we were talking about. Now, what is the effect of these hydrogen bonding? Definitely you can understand that because of hydrogen bonding. Just think about it. I have let's say if I talk about the groups in periodic table. So group 15 that contain nitrogen. Group 16 that contains oxygen. Group 17 that contains fluorine. Okay. Now let's make their hydrides. NH3. What is the state of this? It's a gas. Hydride of fluorine, HF. What's the state of this? That's a gas. Once more. HCl, that's a gas. HBr, that's a gas. But when you talk about the hydride of water, hydride of oxygen, this is liquid. This is liquid. How is it possible? If the previous container as well as the post container, okay, the container that comes later, if both of them are liquid, then both of them are gases, then how can water be liquid? This is a very good question, isn't it? Now, the answer is water can make four hydrogen bond. Water can make four hydrogen bonds. This is the reason why that water is a liquid? Because you try to understand, if you have more intermolecular forces, if you have more intermolecular forces, means hydrogen bond. It's a type of intermolecular force. If you have more intermolecular forces, okay, might be difficult for you to see over here. So let's not write it. Yeah, okay. Yeah, everything is fine. H2 can move four hydrogen. This is what I have, right? Now, intermolecular forces. So if you have more intermolecular forces, then what would happen? Then the boiling point and the melting point, all those things would increase, right? That's why you can see that water has a high boiling point. That's why melting point. That's why it's a boiling point and melting point, both you can say, that's why it's a liquid in room temperature, whereas the other two are gases in the normal temperature. This is how you can talk about the intermolecular forces of different types. Now I want to keep this video short so that we can talk about the next topic in the next videos. So the next videos over there, we are going to step into the pocket region of this chapter, which is the Charles law, Boyle's law, Gay-Lussac's law, the combined law, and the questions from there. So stay tuned in my channel. I'm going to upload the next video very soon, and do watch them as well. If you're really preparing for JEE or any sort of competitive examination, let me tell you, states of matter is one of the easiest chapter when you're reading it. But this is one of the most difficult chapters when you are solving question from here, because there are so many dimensions from where the questions can be asked in this chapter. So I'm going to solve those type of questions, those different type of tricky questions, those were asked in different sort of different sort of entrance examinations. So stay tuned with me and subscribe to my channel. Okay, so that's it for today. Bye everyone.